Good morning, standard 10 students. In today physics chapter lens 1, you have to draw the ray diagram when the object is placed at different position in front of a convex lens or a concave lens. Right. So when you will use the pencil and a scale, right, then you will get the correct value. Right. After drawing the diagram, you have to write the nature of the image form, right, and the application of this system where we use these applications. So one very important one regarding the convex lens, right, when the object is placed between the optical center and focus in front of a convex lens. This one convex lens. This is principal axis. Draw this line. Mark the focus. Right. F2. So two focus are there. Center of curvature. C2. So this distance from the optical center and this distance must be same. Right. I am taking the same median, so focal length will be same. If the median be different, then the focal length will be changed. But the same medium I am considering here, so we have to take this distance and this distance equal. Okay, center of curvature. Then the object is placed between optical center and focus. This is the point. That we have to complete the ray diagram. See, one ray exactly parallel to the principal axis. After refraction, it passes through the focus. Another ray through optical center. When we produce this ray back with dotted line, it appears to meet. When we produce this reflected ray back with dotted line, then it appears to meet. It means this is virtual image will be formed, not a real image. Right? And magnified image will be formed. So highly magnified image will be formed. The nature of the image will be erect, virtual and highly magnified. And this system we use in microscope and magnifying glass. Right? So question will come, what is magnifying glass or microscope? So where we keep the object between optical center and focus in front of a convex lens, then we get highly magnified image. Is it? And nature of the image is erect, virtual and highly magnified image will be formed when we place the object in front of a convex lens between optical center and focus. So this diagram is very important. This is coming in the examination. You have to draw this diagram. Right. After refraction, you have to produce this ray with dotted line back. Then it will meet at some point. Right. So this is the height of the image form. Now the question is, in convex lens, what happened? The style image will be real as well as the virtual. The size of image will be same size, diminished size also and highly magnified also. But in concave lens, the always image will be formed that is diminished one. What? Diminished image will be formed. So you are provided with a convex lens and concave lens. Without touching, you have to find out which one is the convex one and which one is the concave one. So listen here how you would identify. Put the both lens at some distance. Now in front of a convex lens, when we move towards the lens or away from the lens, we will observe that different size of image is formed. Sometimes the same size, sometimes it's a diminished size, sometimes highly magnified. But when we move in front of a concave lens, only diminished image will be formed. Which image? Diminished image will be formed. This identify clearly that the diminished one is a concave lens and the different size is the convex lens. Do you follow? So this type of question is coming examination. You are provided with concave lens and convex lens. Without touching, you have to find out which one is the convex, which one is the concave lens. Clear? So this diagram. In concave lens, this F1, F2, C1, C2, 8. An object, say, complete the ray diagram. One ray parallel to the principal axis, refracted back. When you produce with dotted line, appears to come from the focus. One ray through the optical centers. 8. Wait. Produce back, refracted towards the base, produce back with dotted line, another ray through optical center. There the image will be formed. You can see this is diminished one, right, compared to the object, virtual, right, and erect. These are the nature of the image form while we complete the ray diagram when object is placed in front of a concave lens. Now, there is a defect of eye. Where is the use of this concave lens and convex lens? In eye, as spectacles. Is it? As spectacle, there are two types of disease: long sightedness and short sightedness. Long sightedness means we are unable to see the near object, and short sightedness means we are unable to see the distant object. When we are unable to see the near object, in that disease, in a spectacle, we have to concentrate or focus the distant object to the near one. Sorry, we are unable to see the near one. It means we have to focus the near object to the distance one. For this, we will use the concave lens. So in long sightedness, we use the concave lens, and for the short sightedness means unable to see the distance object. But we unable to see the distance object, but we can see the near object. So we have to focus the part image of the distance one to the near one. For this, we will use the convex lens. Right? So these are the two diseases: long sightedness and short sightedness. Right? Long sightedness means cannot see the near object. Short sightedness means cannot see the distance object. So what is the remedy? Which lens is used in the long sightedness? In long sightedness, we use the concave lens, means the near object you have to focus at distance. Sorry, distance. We have to focus at distance. To focus at distance, or we can say the divert the distance from near to the longer distance. For this, we use the concave, because diverging concave is also diverging lens. And short sightedness, we have to focus the long one to the near one. To focus the near one, we use the convex lens. Right? Then this much is topic in this first exercise. After that, there is the numericals which you have to solve by using the formula 1 by v minus 1 by u is equal to 1 by f. Right? Derivation is not in the syllabus, not included. Only you have to use 1 by v minus 1 by u is equal to 1 by f. Right? So I will explain in the next class how you will use this for 1 by v minus 1 by u is equal to 1 by f plus magnification. Magnification is equal to I by o is equal to b by u. What is I? The height of the image. What is o? Height of the object. What is u? The distance of the object. What is v? Distance of the image. Thank you very much.